Assalamualaikum to everyone. My name is Mama Hanafi Kimi bin Mama Noiza. We are from Group 6 and we are going to present our group project. These are the members of our group and we will be explaining the process of subnetting an IPv4 network. So the goal of this project is to create a new network. There are steps in order to achieve that. So the first step is we will subnet the customer network into multiple subnets. The subnet scheme should be based on the number of host computers required in each subnet, as well as other network consideration like future network and host expansion. Next, after we created a subnetting scheme and completed the table by filling in the missing host and interface IP address, we will configure host PCs, switches, and router interfaces. After the network devices and host PCs have been configured, we will use the ping command to test for network connectivity. We will explain every part right now, starting with the topology. So based on this topology, we must create multiple subnets out of the IP address, which is 192.168.0.0/24 network address space to meet the following requirements. The requirements are the first subnet, which is the LAN A, which requires the minimum number of 50 hosts, and the LAN B, which needs the requirement of 40 hosts. And then we also need to at least 2 additional unused subnets for future network expansion. Therefore, there are a total of 4 subnets, which is the minimum number of subnets required.
Assalamualaikum and hello. Today I want to explain about the answer of question 1F. Given each of the possible subnets mask depicted in the following binary formats, how many subnets and how many hosts are created in each example? As we can see, the hint is, remember that the number of the host bits to the power of 2 defines the number of hosts per subnets minus 2, and the number of subnet bits to the power of 2 defines the number of subnets. The subnet bits shown in bold are the bits that have been borrowed beyond the original network mask of /24. The /24 is the prefix notation and corresponds to a dotted decimal mask of the 255.255.255.0. So in question 1, the prefix is /25. We has been given the binary to find the decimal subnet mask equivalent, number of subnets, and number of hosts. So we can create a table to make it easier for us to find the answer. So the binary in the question 1, as we can see, they have only 1 bits that has been borrowed beyond the original network, and 7 0. So to find a subnet mask, we can use 2 power of 7 because we have 7 0, and the answer is 128. So the subnet mask that we can get is 255.255.255.128. So to find the number of subnets, we can see we only have 1 bits only in this binary. So using the hint that has been given to find the number of subnets, 2 power of 1 equal 2. And to find the number of hosts per subnet by using the hint that has been given, we can find by 2 power of 7 minus 2 implies 128 minus 2. So the answer is 126. So in this binary, we can know that number of hosts per subnet is 126. for the question 2 slash 26, it's just the same as slash 25 on how we find the subnet mask, number of subnet, and number of hosts per subnet. By slash 26, we to find dotted decimal subnet mask equivalent, we can find there are 6 0 and 2 bits, which is 1 1. So to find the end of the subnet mask is 2 power of 6 equal 64. So 64 plus 128. So the answer is 255.255.255.192. So that's the subnet mask for slash 26. To the number of subnets and number of hosts per subnets, we have 2 bits, so 2 power of 2 equal is 4. So we have 4 subnets. For the number of hosts, 2 power of 6 minus 2 implies 64. 64 minus 2 equal 62. For the next question, question 3, the prefix notation is slash 27. So to find subnet mask, we find there is only 5 0. So 2 power of 5 equal 32. So 192 plus 32. So the answer is for subnet mask 255.255.256 224. Sorry. So that's the answer for slash 27 for subnet mask. To find the number of subnets, we only find they only have 3 bits only in the binary. So to find this, 2 power of 3 equal to 8. So the number of subnet is 8. To find the number of hosts per subnet, 2 power of 5, because we have 5 0 minus 2 implies 32 minus 2. So the answer is 30. So the next question, question 4 slash 28. As we can see, we only have 4 0. So 2 power of 4, and the answer is 16. So we just add 16 and 2 to 4, and the answer is for subnet mask 255.255.240. So the number of subnets 2 power of 4 equals 16, and the number of hosts per subnets 2 power of 4 minus 2 implies 16 minus 2 equal 14. So the next question slash 29, we can see we have only 3 0. So 2 power of 3 equal 8. So we just edit it, 255.255.248. That's the answer. So for the number of subnets, as we can see, we have 5 bits. So the answer is 2 power of 5 equal 32, and number of hosts per subnets 2 power of 3, because we have only 3 0 minus 2 implies 8 minus 2 equals 6. For the last question, question 6 slash 30, for the prefix, to find the subnet mask, we can see we have only 2 0. So 2 power of 2, the answer is 4. So we just only calculate 248 plus 4. The answer is 255.255.255.252 for the subnet mask. For number of subnet, as we can see, we have 6 bits. So 2 power of 6 equals 64. And for number of hosts per subnet, 2 power of 2 minus 2, because we're using 2 power of 2 because we have 2 only 0. So implies 4 minus 2 equal 2. So number of hosts per subnet for question 6 is 2. Okay, to find the question of 1G, considering your answer above, which subnets must meet the required minimum number of minimum host addresses? So to find it, we just see the requirement for the subnetting C. The first subnet is the LAN A network. You need a minimum 50 host IP address, so we need a minimum 50 hosts. So by using this table that we already doing, we can find for the 50 and above hosts per subnet. So /26 and 25, because it has 62 hosts and 126 hosts. Okay, so next question, 1H, considering your answer above, which subnets must meet the minimum number of the subnets required? So we read this instruction. The first subnet is the LAN A network. You need the minimum of 50 host IP address. The second subnet is LAN B network. You need a minimum of 40 host IP address. And C, you need at least 2 additional unused subnets for the future network expansion. So we calculate that we need minimum 4 subnets and above. So using this table that we already made, for the number of subnet, that minimum 4 and above is /26 /27 /28 /29 and /30, because it has 4 subnets and above. For /26 it has 4 subnets, and /27 it has 8, /28 it has 16 subnets, /29 it has 32 subnets, and /30 it has 64 subnets. Okay, for the next question, 1I, considering your answer above, which subnet must meet both the required minimum number of hosts and the minimum number of subnets required. So as we can see on this table, /25 it not meet the number of subnet because the minimum requirement is 4, but it has only 2. But for the host subnet, it has 26, so it's fulfill the requirements. So /25 we can use, so we can see /26, the number of subnet is 4, so it's fulfill the requirements for minimum number of subnets. Okay, for the number of hosts per subnets, it has 62 number of hosts per subnet, so it's fulfill the requirements. number of per subnet. Okay, so the answer is slash 26. But we see the slash 27. Slash 27 it has 8 number of subnet. So it's fulfill the requirement, and number of host per subnet is has only 30, so it's not fulfill the minimum number of requirement for number of hosts per subnet. So the answer on this slash 26. Okay, for the answer of question 1J, when you have determined which subnet must meet all the states network requirements, derive each of the subnets. List the subnets from first to last in the table. Remember that the first subnet is 192.198.0.0, which the chosen subnet mask. So we make a table like this, and we just edit first the first subnet that has been given, and we insert the subnet mask meets all the states network requirements that we get from previous question. That is slash 26, and we enter it the subnet mask. So prefix and subnet mask we doesn't change it, so we just enter it all and just change its subnet address. To get 64 in the behind this, we get from the binary, which is 2 power of 6. The answer is 64. So we have 64 addresses. So for the next subnet address, we just edit it. 64 plus 64, the answer is 128. So the answer for the next question, the answer is 192.198.0.128, and the last subnet address that we can get is 192.198.0.192. So this conclude that we have 64 addresses and 62 usable IP address. That's all.
My name is Muhammad Dini bin Shahizad. I would like to demonstrate how to, in the step 2, to fill the missing IP address. Now, as you know, we have to assign the subnet to LA switch and LB switch, as well as PCA and PCB. Now, okay. Now let's look at this one. This is the other. From these tables, we can gather the necessary information to implement the feed to feed the IP address and subnet mask. First of all, this first line is with the first interference. Therefore, the IP address would be this. And the subnet mask would be the this as well. This signs the first line represent the first one. After that, we go to the second interference. Second interference, the IP address we put the first according to the first line. We put also according to the second line. Therefore, the second line of the second IP will be this: 192.168.0.65. Now we put it in here. And then the subnet mask also the same as well. Oops, now put the missing two. Okay, now we go to the L LAN A switch. Now the should be the same but different. So we copy this, paste 2 instead of 1, and same goes to the LAN B switch as well. Copy, paste, and 66 instead. Now then, the subnet mask also the same as well. So we just put it on both of these. And this. Now we go to the default gateway. Now the default gateway was the same as the IP address. Therefore, we put this for the first line, the LA switch, and the second for the LAN B switch, this. Now we are almost finished. Now to the PCA, go to this table. Now we should go look at the last usable IP address. Now look, the first line represent the PCA and the second represent the PCB. Now we just need to take the value, copy, and then this as well. Now for the subnet mask also are the same as well for both PCA and PCB. Now we just need to copy and paste. Yes. Now to the default gateway. Now we take a look also with the same IP address. We just copy paste just like this as well. Now then, now this is the step to the addressing tables in the step 2. All complete.
So in this part, we are going to configure the devices. As you can see here, there are a few steps given on how to configure. So first of all, we have to configure the customer router, and then we have to configure the 2 LAN switches, and finally we have to configure the PC interfaces itself. So let's start with the customer router first. So first of all, we go to customer router, and then we click on CLI, and over here we are given a command line interface. So press enter to start using the CLI, and we have to enable it, and then we have to open up, type in configure terminal, and I'm using tab to finish the sentence easily, and I will type in hostname customer router. So once that's done, we have to enable secret class 123. Oops, my mistake. Secret class 123, and then we have to change to line con 0, and then we have to put in the password, which is password Cisco 123. Now we have to log in. So just type in login, and we open the first gigabit Ethernet interface, which is gigabit Ethernet 00. So just type in interface G00, and now we have to set the IP address, which is 192.168.0.1. So we type in IP address 192.168.0.1. If it's subnet mask, so it says 255.255.255 and 192, and then we press enter. After that, we type in no shutdown, and that's it. So now we have to do for the other Ethernet interface, which is G0/1. So as normal, we do the same thing again, interface G0/1, and then we type in its IP address, which is IP address 192.168.0.65. If it's subnet mask 255.255.255.192. After that, we do the same thing again, no shutdown, and it will say has changed. And then now you have to interface with the serial port. So type in here interface S 0/1/0, and then we put in your IP address 209.165.201.2 if it's subnet 255.255.255 and 250. After that, we type in again no shutdown, and the end. So that's it for the customer router part. Now we look forward to the two LAN A and LAN B. So as you can see here, we have to configure the IP addresses to on interface VLAN 1 on the two customer LAN switches. So we have to make sure to configure the correct default gateway on each switch. So we first off start with LAN A, and we open up the CLI again, of course, and we type in enable, and then it's usually configured terminal, and then we type in interface VLAN because we are going to configure the VLAN port. And over here we put in the IP address, which is IP address 192.168.0.2 255.255.255.192. No shutdown. Now we say it has done things, and now we have to set its default gateway to the given, which is default gateway 192.168.0.1. And what did I do wrong over here? Okay, my mistake over there. I forgot to type in default gateway properly. So over here, instead of gateway, it is gateway. And then that's it for LAN A. Just have to type N, and we are close the console. And we have to do the same thing for LAN B, except that it's for their own IP address. So here we type in enable, configure terminal, we interface VLAN 1, set the IP address to 192.168.0.66 with its subnet 255.255.255.192, and then type in no shutdown and set its default gateway again. Make sure not to mistype it. That is 192.168.0.65, and then we end it. And that is it for both of the LAN ports, and now we just have to set the IP addresses for both PCs. As you can see here, we have to configure its IP address, subnet mask, and its default gateway, which is well written in the table. So we go to PCA, we open up desktop, and we open the IP configuration. So from here, the IPv4 address, just put in the IP address that's assigned to PCA, which is 192.168.0.62, with its subnet mask being 255.255.255.192. And finally, its default gateway, we have to set it, which was given earlier, 192.168.0.1. And that's it for PCA. And do the same thing for PCB. Open here, open desktop, IP configuration, put in the assigned IP address 192.168.0.126, with its subnet mask being the same, 255.255.255.192, and finally the default gateway being 192.168.0.65. And that is it for configuring the devices on the network.
So after finishing configuring these devices, that means all of the devices are connected. So now it's a matter of time that we can use the ping command to test the network connectivity on both subnets. So in order to do that, first we go to the PCA. First we test the ping of set PCA. So we go to the IP configuration, and then as you can see, our address is 192.168.0.62. So we're gonna copy this, and then we will go to the command prompt to test our network connectivity. So the command are ping and then your IP address, which is 192.168.0.62, and then press enter. If it gets a reply, that means the network connection is working. So the PCA is working. So next we will go to the PCB section. So the PCB's IP address is 192.168.0.126. We're gonna do the same thing as the PCA. So we go to the command prompt, and then we will use the ping command, and ping, and then the PCB's IP address, which is the 192.168.0.126, and then press enter. If it gets a reply, that means PCB is also working fine. Okay, and then what about what if the PCA can communicate with PCB? So we go back to the PCA, and then we go to the command prompt, and then we will use the ping command as well, but the IP address will be the IP address from the PCB, which is 192.168.0.126. so 192.168.0.126, and then press enter. If it gets a reply, does it get a reply? Yes, it does receive a reply. So that means both of the subnets are working and are connected together. So yeah, that's probably it for our group project today, and thank you so much for watching. And if you have any questions, leave the comment down below and we will answer it quickly. So thank you so much for watching, and bye bye.